Hello, in this lecture, first we will discuss chain rule. Actually, chain rule, we use chain rule to connect two different functions. For example, if we have a function y is equal to 4t square minus 3t, and x is the function x is equal to 6t cube minus 2. So from these two equations, we can find dy over dt, while here we can find dx over dt. But what if we want to find dy over dx? Change in y or change in this function with respect to this function, because both are depending on one variable, that is t. So that is equal. For this purpose, we use chain rule to connect these two different functions. That dy over dx, and first look at this, that how do we write the chain rule, or how do we connect these two functions. So first you have to draw two lines in front of dy over dx. Here we write dy and here we write dx. So the third variable t, so here and here we write dt. Okay, so dy over dt is equal to dt over dx. So let's take an example for another three functions, for example v, r, and x. And if we want to connect dv over dr, so how do we use a chain rule? So first we draw two lines. Here we write dv and here we write dr. So the third is x, so we use dx here and dx here. So we can then consider another, that a, x, and r. So I want to find dx over dr. So how can I connect these three variables? First, draw two lines. Then here you have to write dx and here you have to write dr. So the third variable is a, then you have to write dA here and here. Look, now take this example that we want to find dy over dx. From this equation, we can find dy over dt. That would be dy over dt is equal to 8t minus 3. So from this equation, we can find dx over dt. dx over dt is equal to 18t square. So now we want to find dy over dx. So dy over dx is 8t. So first write this chain rule, dy over dt dot dt over dx. dy over dt is 8t minus 3, while dt over dx, this is dx by dt, and we need dt over dx, so simply invert this or reciprocate it, dot 1 over 18t square. So this would become 8t minus 3 over 18t square. I hope you get this, that how to write a chain rule to connect more than two functions. So we also use the chain rule for three variable. We will discuss it later. So the next topic is problem involving maximum and minimum values. In last lecture, we learned that how to find the maximum, minimum, or stationary point. Both are stationary point, either maximum or minimum. So look at this question. A closed box with a square base has a total surface area of 36. Find the maximum possible volume of the box. So we area of square base is, this is the just only the base area, is equal to 36 meters square. So we have to find the volume. Volume is equal to that base area, that would be x square multiplied by height. And we have to find the maximum of volume using differentiation. So it means, how can we find the maximum of any curve? First, we find the derivative. So look at the roadmap derivative. So of dx or dh, we will discuss it just in 1 second. We will find the derivative and then we put that is equal to 0. From this equation, we will get the stationary point, where the derivative is 0. So then we will find out that the which point is maximum and which is minimum. So the maximum point will be our answer, because we have to find the maximum of this function or volume. Okay, so first look at this, how to solve these type of question. So remember one thing, because he gave us the area. So what should be the entire area of this box? And the surface area of this box. This is because a closed box, so this has 6 sides. It means the area of entire box would be a closed box with the square base has a total surface area of 36 meter square. It means the total surface area is equal to the base area would be x square plus x square. This would become 2x square, while the sides area, this side, and this, because a square box, so this side area x into h, and we have 4 sides plus 4h. Okay, why we use this formula? Because this function volume contain two variable, so x and h. We can find the derivative of v when we have just only one variable, either x or h. So we will make h or x, or we use the value of h and x from any other equation, because this function should be in one variable. For this purpose, we use the equation of this area. So 4hx, then a is 36, and here if I take, because 2x square, 2x square plus 4hx, so we can make h as a subject. How? 36 minus 2x square is equal to 4hx, and then 36 minus 2x square divided by 4h, 4x is equal to h, because here we cannot make x as a subject because there are 2x. So we will make h as a subject and put this value into this function, that v is equal to x square into 36 minus 2x square over 4x. So because this x can be cancelled with this x, so we just have only one x. So x into 36, this would become 36x divided by 4 minus x. When we multiply x into this would become minus 2x cube over 4. So this would become 9x minus 2 into 4. So this would become 1 by 2x cube. So the next we have to find the maximum of v maximum. We have already v in terms of just only one variable. Now, how do we find the maximum of v? By taking derivative dv over dx. So this would be 9 minus 3 of the derivative of this is 3x square. So it would be 3 by 2x square. So now put this is equal to 0. 9 minus 3 by 2x square is equal to, so put equal to 0. So this would be 9 is equal to 3 by 2x square. 9 2 times 18 divided by 3. 9 it would be 6 is equal to x square, and x will be plus minus square root of 6. So x is, now we have two values, x is equal to plus square root of 6 and minus square root of 6. So we don't know which is maximum and which is minimum. So because in this question, this is a practical question, or we have a word problem. So we know that x is the length of this box, so the length can never be negative. So he said find the maximum value of V. So we use always a positive value. If we are not sure that what is X, either it is a length or any other thing, then how can we find the maximum value of V? By using a first derivative or second derivative test. So just find that a second derivative of this volume and then use plus 6 and minus 6 one after another, then you will find which is maximum and which is minimum. So because we know that X would be plus square root of 6 for the maximum volume. So V will be, V is equal to 9 into square root of 6 minus 1 by 2 and square root of 6 cube. So calculated, it would be the final answer, I think, by using calculator, 6 square root of 6 meter cube. You can find it by using calculator. So the next question is that so look at this, just 1 minute, please. W is equal to PQ and 2P plus 5Q is 100. Find the maximum value of W. So again, look at this. We have to find the maximum value of this function. And if you are looking at this function, so it contains two type of variable, P and Q. So I tell you that we should have just only one variable here, that we can find the derivative of W with respect to that function. And after that, we will use the same technique to find the minimum or maximum. So how can we convert this function into one variable? Now the other equation we have, so make P or Q subject from this equation. So I'm going to make Q subject from this equation. So Q will be 100 minus 2P divided by 5 and put this value into this function. So W is equal to P into 100 minus 2P divided by 5. So then 100p into 100p divided by 5, it would be 20p minus p square and 2p square divided by 5. So we have to find the maximum of this function W. So first we will find the derivative dw over dp. It would be 20 minus 4p over 5. And put this derivative is equal to 0. 4p over 5 equal to 0. Then 4p over 5 is equal to 20 and 500 and p would be 25. Because now we have just only one point, p is equal to 25. It means we don't have any other point, so this is the maximum point. If you look at this, this is a quadratic equation. You can also 20 W is equal to 20p minus p squared. So quadratic equation, the coefficient of p square is negative. So it always be like this, open downward. So this is where the p is 25. So this point will be the maximum. So use this p value into this W and you will find the maximum value of W. W is equal to 20 into 25 minus 2 into 25 square divided by 5. So 0 and 500 minus 25 square 625 and 625 divided by 5 125 into 2 250. So 500 minus 250 is equal to 250. This is our answer. This is the maximum W max. Okay, take some more example. A tank in the shape of right circular cylinder with no top has the surface area of 3 pi. It means this is a tank and a tank is open because there is no top, open side. So surface area, the surface area, it means the curved surface area plus base area. So 3 pi meter square. What height and base radius will maximize the volume of the cylinder? That we have to find the maximum of volume. He said what height and base radius will maximize the volume of the cylinder. So we know that volume of the cylinder is pi r square dot h. Again, look at this. We have two variable r and h, where pi is constant. I said we can find the maximum of v until unless we have this function in form of just only one parameter on one variable. So for this purpose, we have to make somewhere h or r as a subject, and we put the value of h and r in this function. He said the surface area is 3 pi meter square. The surface area of this cylinder would be A is equal to base area, that is pi r square, and the curved surface area, which is 2 pi r h. Area is 3 pi, so take pi as a common, and r square plus 2r dot h. So pi and pi cancel. So 3 minus r square divided by 2r is equal to h. So here we can make h as a subject because we cannot make r as a subject from this function. So put this value into this function. It is similar to that example which we solved earlier. So pi r square 3 minus r square over 2r. So r can be cancelled with 1r. So pi r, this would become 3 pi r divided by 2 minus pi r into r. This would become pi r cube divided by 2. So now we have to find the V maximum. So take derivative of V maximum. V max is equal to 3 pi by 2 minus, when you take derivative of this, so 3 pi r square divided by 2. So put them equal to 0. This is actually dV over dr. So 3 pi by 2 minus 3 pi r square over 2 equal to 0. So find r from here. 3 pi by 2 is equal to 3 pi r square divided by 2. So 3 pi cancel, 2 and 2 cancel. So r square would be equal to plus 1. So when you take square root, it would be plus minus 1. Plus minus 1. So again, look, we know that the radius can never be negative. So r is 1 to find the maximum volume. So r would be the 1. So in this way, we can find the maximum volume. V is equal to 3 pi for this equation, 3 pi over 2 into 1 minus pi over 2. And 3 pi over 2 is the LCM. 3 pi minus pi, it will be 2 pi over 2, or simply pi centimeter cube. So he said find the radius and the height for this, that the volume of the cylinder will be maximum. So we have already find the radius. So how can we find the height? Just put this value into this equation where h is a subject. So here h is a subject. H is equal to 3 minus 1 over 2. So 3 minus 1, 2 over 2, h will also be 1. So this is the height and radius of the cylinder for this, for which the volume of the cylinder has maximum or will be maximum. So the next and the last example, no, we have just one more example here. The sector of a circle radius r has a perimeter of 20 centimeter. The angle of the sector is theta radian and the area is a centimeter square. Find the maximum possible area of the sector. It means you have to find the area maximum of the sector. It means the formula of area of the sector is 1 by 2 r square dot theta, while theta in radian. He's talking about sector, so we use the area formula for area of sector. So the sector of a circle, radius r and perimeter 20. First draw a circle, then a sector whose the perimeter is 20 and radius is r. This is angle theta. And the perimeter, this entire length, which this, and this is 20. So the angle sector is theta radian and the area is c. So how we can write S is equal to r theta. So S is 20. R, no, not S is 20, but I'm sorry, that the perimeter is 20. So how can we write the perimeter? P is equal to 20. That consists of 2 radius and 1 arc length. R plus R theta is equal to 20. So this would become 2R plus R theta is equal to 20. So I said here we have to find the A maximum. For this purpose, this function should be in one variable, either x, either or theta. So where we have to replace this theta or r from this equation. So you can take theta, you can make theta as a subject, or you can make r as a subject. So if you take r as a common, so I'm going to make theta as a subject from this equation. Theta 20 minus 2r divided by r. So put this value into this function. A is equal to 1 by 2 r square and 20 minus 2r divided by r. So 1 r can be cancelled with 1 r. So 1 by 2 r into 20 minus 1 by 2 r into 2r. So this would become 2 and 10 r minus this would become 2 and 2 cancel. So r square. So now we have to find the maximum of A. So take, for this purpose, take derivative dA by dt dr. So this is 10 minus 2r. So put equal to 0. When you put is equal to 0, r will be 5. So he find the maximum possible area of the sector. Put this value into this area. You will find where in this equation where r is just, there is only one variable, that is r. So equation number 1. So A will be maximum when r is equal to 5. 10 into 5 minus 5 whole square. So 10 into 5, 50 minus 25. It would be 25 units square. That was, yes, centimeter. So centimeter square. So the next question is, a cylinder with an open top has a radius r centimeter and the volume is 512 by centimeter cube. So cylinder with the open top, radius r. First look at this. This is cylinder, an open top, because we don't have any top. V is 512 pi. Write down the surface area of the cylinder in terms of r. The surface area of cylinder would be A is equal to that A is equal to pi r square, base area, and plus height, 2 pi r into h. And he said write down the surface area of the cylinder in terms of r. It means we have to replace h, or we have to eliminate this h. So for this purpose we have this equation. So pi r square dot h is equal to 512 pi. So we can cancel pi with this pi. So h will be 512 over r square. So use this value into this equation. So pi r square plus 2 pi r into 512 over r square. So this pi r square plus 2 pi 1 r will be cancelled. 2 pi into 512 divided by r, and the final equation will be pi r square plus 512 into 512, 1024 pi over r. So the next, find the minimum surface area, leave your answer in terms of pi. Minimum, again, we use a derivative that A minimum dA by dr. So this would be 2 pi r plus, first you have to write this function into this form, 1024 pi and r power -1. So we write power first, and then 1 decrease. This is constant, this will remain same. 1024 pi. So we write power first and 1 decrease from power. This would become minus r square. So put this is equal to 0. 2 pi r minus 1024 pi divided by r square equal to 0. So multiply r square with whole equation. This would become 2 pi r cube minus 1024 pi is equal to 0. So 2 pi r cube is equal to 1024 pi. Pi and pi cancel, and r cube will be, when we divide this, this would become 512. And when we take cube root of 512, it would be 8. So r is 8 when the area will be minimum. So r is 8 for, he said, to find the minimum area or maximum. So, sorry, find the minimum surface area, leave your answer. So when r is 8, the area will be minimum because we have just only one point, that is r is equal to 8. Find the value of r and the height h of the cylinder. Value of r. So first r is already there, 8, and how can we find h? Put this value into this function. So you can find h. H will be 512. Our r is 8 square, that would be 64. So 8 time and 8 6 time, 3 carry, and 8 4 time, 8 1 time, and 8 time. The age will also be 8. So height and radius will be 8. So this is just all about the question about the maximum and practical question about maximum and minimum. So thank you so much. We'll see you in next lecture.